solution. We're going to look at several server-side solutions, and then we'll wrap up talking about conversational UIs on Android. Does that make sense? Yeah? But all Java, which makes it fun. So then, the way we're going to get started with this is by talking about the JSpeech API or the JS API. Now, there are lots of different APIs out there. If I asked you something silly like, how many of you use the JDBC API? Show of hands. Kind of a silly question, right? Everyone has probably talked to a database in one way or the other. But we understand how the JDBC API works. It's a generic set of interfaces. And then if you want to talk to a specific database, you need to have a database driver. Yeah? JS API works much the same way. Only what you end up with is a common set of libraries for doing speech synthesis and speech recognition. And then you have a bunch of pluggable voices that you have instead of database drivers. So I like thinking of JS API kind of like JDBC. It's something that is well understood, and it's something that Java does incredibly well, which is setting up standard interfaces where we can plug in custom implementations all day long. So there is a wonderful FAQ on the JS API out on the interwebs right there. And so let's walk through some of the most common questions. Like, let me ask you a frequently asked question before we get started. Have any of you worked with the JS API before? No. Ah, you're my target demographic then, right? It was a bit of a trick question because JS API technically doesn't ship with the JDK, which makes it really hard for you to end up using it even accidentally, right? Java has done this, or Microsoft, excuse me, not Microsoft, my goodness, Oracle has done this with a lot of their most advanced libraries, which unfortunately tend to be the least used of the libraries as well. Are any of you doing anything with imagery, big high-end imagery, satellite imagery, things like that? No. What are you doing with your lives? That's what I want to know. I worked for several satellite imaging companies, and we ended up dealing with very large images that were 40,000 pixels wide by n pixels long. I was creating 4,000 pixel thumbnails out of those kinds of images. 4,000 pixel thumbnails? Yeah, absolutely. But in order to deal with very large images like that, Java didn't ship with the libraries you needed. And for some of the specific formats we needed, like GeoTIFF, which were TIFF files, which it doesn't deal with very well to begin with, but adding geo information on top of that. So we ended up having to go out and pull down not only the interfaces, but the implementation when we wanted to use more high-end libraries like that. So this shouldn't scare anyone. You should be like, oh, well, maybe that's why this isn't more popular, because it's not easy to use. But once you download the JS API, you'll be able to turn around and begin doing things with it. And as they say, it is a cross-platform API to support both dictation or speech recognition, as well as speech synthesis. Speech synthesis is text to speech, and speech recognition, of course, is speech to text. So this spec has about 70 or so classes or interfaces. We're just going to scratch the surface here. This is really meant to be more of a survey than a deep dive in. But it is well documented, and when you download and install it, it comes with a full set of Javadoc APIs that you'll be able to take a look at as well. You'll also see some specifications. format. In fact, when this finally shipped, it ended up being called SSML, but we still have GIDS.Java, the JSpeech grammar format specification in there. So there's a little bit of mismatch in there, but hey, consistency is the last refuge of the unimaginative, right? So, when Sun was working on this spec, they were working with a lot of leaders at the time. Now, it's funny that Apple is listed first, right? This spec was being worked on in the late 90s. Apple was working on conversational UIs back in the late 90s. We're only now beginning to see Siri come to fruition because more than anything else, these are tiny little quad-core processors that we're carrying around in our pocket. The 1998 time frame, we didn't really have smartphones that had that level of capability, right? And so it was very early days for that. But the reason why conversational UIs are so popular nowadays is the hardware has finally caught up with the promise of the conversational APIs. So, but Apple was there. You might have heard of DragonSpeak. That was desktop software that allowed you to do these kinds of things. Shouldn't surprise us that we see IBM in place. Do you know about the Ibm Watson Project? Yeah, what's Watson? Help me out. How would I know Watson if I had never heard of it before? It does everything. It wins Jeopardy, doesn't it? So Watson, that's like a very public version of what it does. It really is an AI system. And one part of the AI system is the conversational UI aspect of it. When we were on Jeopardy, when all of us were on Jeopardy, when Watson was on Jeopardy, right? They weren't typing in questions. Alex Trebek wasn't typing in questions. He was saying the questions. So one part of the Watson API is understanding the spoken questions. Then it did all of the AI it needed to figure out what the answer was. And then did it force us to read the answers? No, of course not. Watson had a voice, so it did text to speech as well. So even though this is how big the Watson API is, we can use this much of it to deal with speech recognition and speech synthesis. So these are all examples that we're going to see moving forward here. As I said, I'm going to give you 4 different examples because I want you to be able to notice the similarities as well as the differences. So we've got all the time in the world. When we go on and start reading about the implementations, it's a little bit odd because you don't go to the MySQL website and download JDBC along with the MySQL driver. JDBC is shipped with the JDK. You just plug in the driver. Well, JSPI was a little bit different. That most every implementation you come across, you'll download not only the voices and the libraries and things like that, but you'll download an implementation of JS API with it. So anytime you go looking for any of these things, they always will ship with a copy of that jar as well. Does that make sense? Yeah, good. So free TTS is what we'll focus on first. It's an open source project. It's a university-based project. So it's really not something I would ever use in production. You'll hear the voices sound pretty rough. You know, the API is a little bit rough, but it's free and it's client-side and something we can get started with. IBM's speech for Java no longer exists, but the Watson project does, so we'll take a look at that API as well. But we want to get started with free TTS because at some point we've got to get a nice little hello world in place. At some point we've got to get one example, we got to get our computer making noise. And once we make noise once, we can do it a whole bunch of times. But free TTS is not anything that I'd recommend you use other than to download and experiment with. But we can do that. Free TTS, to give you an idea of how old this project is, if you go looking, it's still out there on a variety of different repos, but it is out there on GitHub. So I recommend pulling it down from GitHub. You'll see that it's a speech synthesis system. So we're not going to deal at all with speech recognition here. This is simply text-to-speech. The reason for that is that speech recognition requires terabytes of data, if not petabytes. It requires a ton of computational processing that goes on, not the least of which includes a lot of AI that goes along with it. Because if you can imagine, going from text to speech is fairly easy. You could take your text, split on the spaces, look up in a dictionary, match that word with a pronunciation of the dictionary, and kind of go about your business that way. So that's why speech synthesis is something you can deal with locally, and it's fairly computationally easy to get accomplished. But speech recognition, as we move forward with any of our examples beyond this, we're going to find that they're all server-based, and most of them assume that you'll be running in the cloud. Yeah? But this is speech synthesis. It's a nice, small, fast runtime speech synthesis engine. It supports pluggable voices, and it came out of Carnegie Mellon. So, if we want to, yeah, please. Sphinx, no. It very well might be. Let's take a look. Sphinx, speech. Oh, hey, there we go. CMU Sphinx. Have you worked with it before? There we go. Pocket Sphinx is a standalone app on Android. Yeah, it looks like it's still alive. That is great. So what does our tutorial have to say for us? I always like looking for a quick little hello world. It must be in Java if they say Android. Yeah. So voice control, but speech transcription, speech translation. So this does sound like it's dealing with both speech recognition and text. So before you start building, oh, come on, give me the easiest one you can. Good, 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 good. All right, so dependencies, yes, yes, yes. That's what I'm looking for. All right. So this is a transcriber. Yeah, so this does look like it's doing a lot of speech recognition in there. Again, I've never seen this code before, so that always makes it fun, doesn't it? I'm really glad you brought this up. No, I really am, legitimately. So taking a look at this right now, we got some configuration, and these are the kinds of things I was talking about. Those kinds of things, those acoustic models to represent all the different things we can say. Because these models don't think in terms of words like we do. We think of these in terms of letters and words, and it actually thinks of these in terms of phonemes, pronunciation, sounds. So a lot of this modeling that has to do in here are language specific, but it can even be dialect specific or accent specific as well out there. If I had a thick southern accent, it would have a hard time understanding me. Just like you have a hard time understanding me, right? So yeah, so we've got, let's see here, model, a dictionary, a language model path, whatever that is. But here's my recognizer right here. You can see what they're doing. They're taking a sound file and streaming that in. They're going to start the recognition. They're going to come up with a result. They're going to get the result, and it's going to say, here's, oh, I love that. Here's our hypothesis. Here's what we think you do. Speech recognition is almost like geocoding. When you type in an address in Google, 123 Main Street, it'll always come back with a latitude, longitude point and a confidence value saying, I'm pretty sure this is what you're talking about, or I'm not sure as all. So I'm guessing that in this hypothesis, not only will it have a transcript, but it'll probably have confidence level as well. This is awesome. I'm so glad you brought this up. There you go. If I was feeling really brave, I would download it and run it, but that exceeds my bravery for this demo. But let's keep that in mind. That is that's very, very cool. All right. Here we are. So I've already gone to all the trouble of compiling this and everything else. We'll pull up the source code and take a look. But I want to get that easy win in right off the bat. So here we go, easy win time. I'll make this embiggened so you can see it. There we go. So down in this lib directory, in the bin directory, is a fine little jar named Hello World. So just like Michael Carducci, right? Nothing up my sleeve. Yeah. I'm going to come in here right now and run that Hello World jar. And if everything goes well, wait for it, wait for it, wait for it.
Hello World.
Oh, wow. Isn't that amazing? All right, that's all the time we have. Thank you very much. I hope you enjoyed it. Yeah? So one of the things, oh no. Interesting. Couldn't find lexicon data for, yeah, all right. It's trying to list out the voices it knows about. And so it's got a couple of Kevins in here, but it was using voice Kevin 16. So one of the things I could also do as well, I don't know if we'll notice a huge difference, but I can provide a different voice.
Hello World.
Let's see if we can tell any measurable difference.
Hello World.
Yeah, I couldn't tell a whole lot, could you? But let's turn around now and take a look at some of that source code and see what kind of magic we can make. So here is that Hello World that we were just looking at right here. So I'm in the free TTS directory and in the demos directory, and here is our Hello World. So as we're coming along in here, one of the first things they're doing is saying, hey, you know, if we don't have a synthesizer, bad things will occur. It can be a little bit weird. You need to make sure that this API is in your class path. You need to make sure a setting file is in a home directory or other places like that. You need to make sure that your voices are loaded. So there are a lot of moving parts. And so it's always good to have some kind of sanity checker in here, just making sure that everything is okay. A very common thing that you're going to end up doing is thinking in terms of voices. In the browser, you have a number of voices, male voices, female voices, and voices associated with particular locales as well. If I set the language of my text to be English, but I set my locale to be India, it will end up reading my English with an Indian accent, which is fun. But if you set the language to Indian or Hindi, and then associate an Indian voice with a Hindi language, it will read those up. So you do have two different things that you associate with. You have the actual language that you're dealing with, but then you have the voices that tend to be locale specific. This is how we can have your GPS read you back directions with a British accent, yeah? Or you can actually change your locale so everything is thought of in terms of English. So we're just kind of going through here listing out the various names. So they're just trying to get a synthesizer out of this and getting all the available synthesizers. And once they have it, they're walking through the engine list, trying to get everything and just building up that list. So here is where the fun begins. Because what we're going to do is we're going to get that engine, we're going to get all the voices, we're going to make sure that we are setting the voice that we want to do. So we can see there's all kinds of boilerplate, all kinds of setup work that we have to do. It's almost a letdown when we finally get to line 162 with that symbol method speak plain text, right? So there's a lot of code going on in there, but we can see what we're trying to do is we're trying to gather up all our voices, we're trying to deal with our locales, we're trying to set everything up so we can turn around and just speak. What's really nice is that there are a lot of events that go on. We can figure out that we're speaking, so there's an event that gets thrown while we're speaking, but in this case, what they're waiting to do is we can plug as many things into that speech queue as we wanted, and we're just trying to wait for that entire queue to bleed dry. Once the entire queue is empty, then we can come down here and deallocate the synthesizer and exit. Does that make sense? Yeah? So there's a lot more we could do in here, a lot of poking and playing around in here. You know, doing things like dealing with mixed voices. So in this case, we know that we're going to be dealing with several different voices, Alan and Kevin 16, and these voices, you can see have various attributes associated with them as well. We could just look for female voices or just look for male voices. They have age, which I think is kind of interesting as well. That's not a typical setting, but it's kind of an interesting setting. I want an old man to read this back, or I want a young boy to read this back. So once we start digging into these APIs, there are all kinds of clever things you'll get at. But once we start speaking down here, come on, show me, show me, show me. We're setting some various voices. And we're dealing with events. Markers, the speakable event. So all through this, we could have a more interactive way of making sure that as Kevin is speaking, we could pause Kevin, go off and do something else, resume Kevin, change Kevin's voice to Susie, and move on from there. So as I said, this is a great place for us to get started because it's got some really interesting events and things we can take a look at. I've never done anything on word boundaries, but I find it interesting that that's a particular event that you can subscribe to as well. So, as much fun as this was,
Hello world.
we can do a little bit more sophisticated work than just that. So, included in the slides, of course, is the interesting source code so we can go out and read about this after the fact. I told you that the JS API has about 70 or so classes and interfaces associated with it. The primary one that you'll be interested in is that synthesizer. We saw the synthesizer sometimes they'll call it the engine as well, the synthesizer engine, is where you deal with locales and deal with voices and set up all of your state and then have it do the reading for you. So we were doing a speak plain text, and you'll notice that you can associate a listener with individual invocations as well. So I mean, I love the fact that this is something you've never done before, but it should feel very familiar to you. It's like, oh, of course I'm going to have these events, and oh, of course I'm going to have this, and oh, of course I'm going to have these other kinds of things. Many times you're going to be dealing with plain text. So this speak plain text is just what it sounds like. Remember, there's also SSML. And SSML allows us to do more fine-grained things with our speech. So, for example, the speech synthesis markup language. There's the example that I'm looking for. Prove it in code, right? So this is what SSML ends up looking like. It's just like HTML, but HTML is hypertext markup language, and SSML is simple speech markup language. So SSML is in fact for voice browsers, not web browsers. So you'll find a lot of similarities as you're looking at this. Like instead of starting with HTML elements, you'll start with a speak element. Now HTML has things like, oh, that wasn't the example I was hoping to show you here. Come on. When I zoomed in, I didn't realize how much I zoomed in. Let me find my place here real quick. I apologize. I wanted to show you the simplest possible one first. Oh, rats, I can't believe I'm not going to find the simplest one. There, oh, of course, there it is, right after I complained about it, yeah? I lost it again, I can't believe. All right, I'm not zooming anymore. This will be a perfect one right here. So, HTML document with paragraph elements again, but realize, again, we're dealing with a vocal browser, a voice browser, and so there's going to be a natural pause at the end of every paragraph. There are also sentences in here, so there will be nice natural pauses at the end of the sentence as well. Yeah? And in HTML, that would be a BR element. Here we can put a break. So we can even say, hey, the first was from Stephanie Williams and arrived at 3:45 p.m. So the other method in that synthesizer is not speak plain text, it's actually speak SSML. And what that means then is you'll pass it this well-formed SSML, XML document, it'll parse it up, but it'll start doing interesting things with paragraphs and sentences and voices and prosody, which is slowing down your speech or speeding it up for emphasis, good things like that. But what's nice is that we have the ability to manage all of that kind of thing declaratively. We have the way to lay this stuff all out and ensure that no matter what library we use to play it back, all of this emphasis is associated with the document, not the APIs you happen to be using. Yeah? Ah, very good. All right. We are having fun now. So then, Mary TTS is another one. TTS, text to speech. That's kind of a good just kind of Google term in general, right? If you wanted to type in Java TTS, you'll end up coming with a whole bunch of different libraries and options available to you. Free TTS is a great learning tool. I wouldn't use it in production. Mary TTS, I actually would. This is also a university-based one. This one is more European than local. So it's interesting. Many of the examples, they use German voices, not English voices. The nerve, right? But this project is very modern, very up to date. Free TTS, it looks like, hasn't been updated since about 2014, right? So either an instructor went on a really long sabbatical or they lost funding or something like that. But this is not abandonware by any stretch of the imagination. And so, Mary, I apologize for the truncation there. Mary stands for Modular Architecture for Research in Synthesis. Yeah. It's fun that they were being clever about this. But this modular architecture for research in synthesis is what we're dealing with. So Mary TTS is up in GitHub, and this is what I love doing. Any project, I want to go to GitHub, clone it, either run npm install, or in this case, they tell me to do a Gradle-W run, and we're up and running in no time. So this is the hallmark of a nice project as well. So let's do that. Let's come out here right now. Thanks, Free TTS. Here is Mary TTS. Here's everything that's going on in there, but all I'm going to do is do a simple Gradle-W run. I always get worried about this, right? Am I going to have to download the internet? Up to date, cache. Oh, the tension is killing me. All right, it worked. I shouldn't sound so surprised, right? But what's interesting about this is you'll see that Mary TTS is running on a port. Free TTS was implemented as a client-side library. Mary TTS deals with both voice recognition as well as speech synthesis. So Mary is actually implemented as a server. She says, especially for the speech recognition, you're probably going to be running this on your own iron somewhere up in the cloud. So the way you're going to interact with Mary is just through HTTP. It's kind of odd if you were hoping to just do everything locally, but realistically, you're not going to do everything locally. If you're dealing with Androids, you're going to be sending this over the wire. And so it's not as odd as it might seem initially at first blush, but it would catch you by surprise if you're expecting something else. So here we are, we're running on port 59125. That was for my benefit. I'm a bear of very little memory. All right, localhost. And it took too long, I forgot already. All right, 59125, 59125. My wife has an amazing memory for that. She remembers every phone number she's ever had. She remembers the entire family's social security number, complete strangers' birthdays. I don't know how she does it. And I can't remember a port number long enough to alt-tab between a console and a video browser. So here's the web client that we get visiting this. You'll see that we will be able to play around with a variety of different inputs, including, there's our good friend SSML right in there. But we're going to focus on plain text as we go along. We can also talk about what kind of different output we want out of this. we're going to actually have this stream audio back to us because we want to be able to listen to it. But it is interesting to see it break up into parts of speech or words or tokens. Tokens is especially interesting because that actually allows you to kind of see the implementation as it goes. But we're going to focus on audio right now because we like happy working demos. Someone tweeted yesterday, all of Scott's conversational UI examples involved marsala dosa. So I definitely have to do this as well here. I would like some masala dosa, please. Yeah? I could choose any number of voices in here. There's only one voice preloaded. But I could do all manner of fun audio effects on her. I can turn her into a robot or make her sound like she's at a stadium. We'll play with that in just a moment. But let's do the easiest one first.
I would like some masala dosa, please.
There you go. Now, if you wanted to hear what it sounds like if she whispered that to you.
I would like some masala dosa, please.
That sounds frightening, doesn't it? A robot?
I would like some masala dosa, please.
That's a dosa bot, right? Yeah. And there are a number of other effects you can throw in there as well. Echo.
I would like some masala dosa, please.
So all of this gives you an idea. Can you immediately tell how much nicer her voice sounds? You know, so that's what, 20 years of technology has done for you right there as well. But again, all of this is us interacting with the server. So a lot more things that can be going on, a lot of these effects and different things like that. But just for grins, if we wanted to break this up into words, we could say, I would like some masala dosa, please. And begin seeing, I would like some masala dosa, please. So this is another fun learning tool that allows you to begin getting a glimpse of what's going on under the covers. I have 10 minutes left, is that correct? Ah, wonderful. All the time in the world. All right. So the third option we have available to us is IBM Watson. Now, what's nice about Mary TTS is you can see we were actually able to download her and run her locally or run her on our own server infrastructure as it goes along. Something like IBM Watson, you're going to be interacting with this purely as services as software as a service. You're going to purely be making API calls out to this. That means that you're going to be paying for those API calls as well. Of course, they'll give you lots of nice developer credits to get started with, and your thresholds, if they stay pretty low, you can experiment with this without having to pay a lot of money associated with it. But what we're doing as we move along here is we are moving our way up the professionalism scale as well. This is professionally developed software. Of course, you're going to have to pay for it, but you're going to get the best output out of it as well. Yeah. She does. Yep. And that's actually how it was working. That's a great question. Where you at, Mary? Talk to me here.
I would like some masala dosa, please.
I was expecting you to update this. Perhaps this is what I want. So here we go. Yep. So I can ask what the version is of Mary. There we go. It's a 6.0 snapshot. What kind of data types are available? There we go. What kind of locales do I know about? So, yep, it's all right there, just an example. Yeah, lots of fun stuff. Are you thinking of demos, or are you thinking of things you might actually do on your own? Both, of course. When you have other speakers in the audience, they're like, I'm stealing that demo from you. And that's fine. I would love that. I'm sorry? Ha ha ha! That's a wonderful question. Does SSML have style sheets? Not that I'm aware of. That's all handled internally to that. So it is more of a data format, more of an XML format than a markup or a layout format. Yeah. Not through CSS. I'd have to think more about how you do that. Yeah, not through CSS, but yeah, that's interesting. I like that. All right. We were talking to our good friends at IBM now. And like I said, the Watson API is this big. There are lots of interesting things going on, but what you can do is use this much of it, which is kind of the I/O aspects of it. And I/O, not necessarily file I/O, but conversational I/O. So all of this Watson source code is up on GitHub. So I would encourage you to go out there, clone the source code. Can you tell how I like learning software? Prove it in code, right? In every case, I'm trying to give you working examples of this software so you can pull it down and run it. What's unfortunate about this particular example is you have to have a Bluemix account and you have to do all of these things online. So I'm not going to be able to live demo this for you. I apologize about that. But if you've spent any time with doing any kind of Bluemix work at all, it should feel fairly familiar to you. Of course, have what toolkit do you have to deal with Bluemix? Oh, you have the Cloud Foundry toolkit. Yeah, so you pull down Cloud Foundry and you interact with it that way. They have Maven builds, which surprised me for the Watson stuff, not Gradle builds, but go figure, right? That'll get us to where we need to go. This is their online demo, and so this isn't any code at all I have locally. I am actually pulling this all from across the wire. So this is giving you an idea that it's like, oh, hey, here are the various languages I recognize. But here is the transcribe that you can deal with. This is nice because once again, this is showing us what text are we expecting, or excuse me, what language are we expecting to come in right here. So I'm expecting US English, not necessarily UK English or anything else. But once I specify this is what I'm expecting to come in, I can record the audio or play back things. Let's record some audio first. I would like some masala dosa, please. Oh no. That's terrible. That wasn't it. All right, let's try this again. All right. I would like some masala dosa, please. Go on. Oh no! The demo gods have been so happy with me and now they do this to me. I would like some masala dosa, please. I would like a solid dosa, please. All right, I'll take that as well. Yeah, is that close? Yeah. Stop it now, please, before it does more. A very common thing to do, if you want to think of this as a bit of a unit test, is to turn around and have audio samples. So it'll be the same voice and the same intonation and the same words every time.
My family absolutely is fascinated by the work that I'm doing with Watson, and I think they feel a personal sense of pride and satisfaction with the fact that it's not just technology for technology's sake, it's technology that's actually making a difference and changing the world. My
Somehow
family absolutely is fascinated by the work that I'm doing with Watson, and I
there we go. The accuracy was pretty darn good on that, but again, that was the sample that they were using. That was probably a control that they were really using to train this. This is a well understood. He's one of the researchers as well, so they recognize his voice. This is a well understood piece of text. We shouldn't expect that perfect level of transcription. We should expect the level of perfection we got out of me, not the sample right there. But it is incredible that this is where we're moving towards right now, where we can just do kind of free form speaking and have it recognize and transcribe. Not there yet, but we're getting awful close. So, if you want to begin using this kind of stuff, here's how you would bring in that particular piece, that text-to-speech in Maven. Here's how you would bring it in Gradle. And then down here, once again, you would simply new up a text-to-speech. Since it is a web service, you will have to provide a username and password. That's what's effectively logging you in. But then you get voices and go about your business. Are you beginning to see these patterns form now? So what I like is that seeing it done in a variety of different ways, you start seeing, all right, I could probably handle this right now. I'm seeing the same common elements show up over and over again. So this is a more full-fledged version of that HTTP servlet that came up. So there's our text service right there. Here's some details out of there, but there's our synthesize as we go along. So this is the Watson example for doing text-to-speech. I didn't demonstrate that for you, but I just wanted to show you once again that once you've synthesized speech once, you've pretty much done it over and over and over again. Part of that is because of the JS API. It gives you that consistency that you were looking for. But that consistency holds true across languages as well. This is a very common way to manage this in JavaScript as well. So in the few moments we have left, I wanted to give you an Android example. And what I wanted to do with this Android example is not just to show you yet another speech synthesis example, because I think you're getting it at this point. But I wanted to give you an example of how you might end up using it. So what's interesting about this example is that it's on Android. So we've now demonstrated how to do local speech synthesis. We've shown you how to do cloud-based speech synthesis. This is something that you're going to do on board on your Android phone. But specifically, we're going to set this up so as incoming SMS messages come in, it will wake up, speak them out loud. And I think you'll be amazed at how few lines of code it actually takes. So this is a great example you'll be able to find online. And again, the mind notes are online as well. But what we'll end up doing with this Android app is going in. This example is a little bit dated, but again, it shows you how old these APIs are and how well supported they are. I don't know if you were noticing, but SSML, that was a spec that came from like 2000 or 2002. So a lot of these specs have been around for quite some time. 2.2, what was that? Oh, that's right here. That's Froyo. So that's a nice old version of Android. Since our Android app is going to be interacting with these various things, we have to set up the permissions to read the SMS. Some people get confused when I'm doing this and say, you need that for speech recognition? No, you need this for this particular example that we're doing here, right? So you don't need to give SMS permission to do normal speech synthesis. But now that we have permission to read those things, they say this isn't required, but it's good practice to begin putting your text in files. Normally we say it's good practice so you've got reusability and you've got internationalization support, I-18N support. Now we've got another thing. We're going to begin putting our spoken word responses in there and let it talk them back to us as well. So we've got yet another reason why it's a good idea to externalize your messages so they can be spoken just as easily as they can be internationalized. But we're going to have this helper class. In this case, they're calling it a speaker, and it's going to be an on-init listener. There is your TTS library that comes native with Android. So what we're going to do is say, hey, I need to turn around and be listening to on-init, because on-init I want to do all of my bootstrapping so we can begin talking. So here's what our on-init would look like. It's making sure that that text-to-speech library is there. And if it is there and initialized, then we're going to go ahead and set our language and say we're ready to start talking. So the same thing we're seeing all along here with voices and locales is going on. But now, once we give an actual speak, and notice this is just taking plain text, you're probably not going to get SSML from your SMS provider, although that would be really cool, wouldn't it? But you're probably going to be dealing with plain text in here. So amidst all of that, you've got your TTS speak, passing in the message itself, the cue, and so on and so forth. So this is what the piece would look like when we're actually receiving our messages. Notice we're now on receive right there. So as that message came in, we're going to get the contact name, we're going to pause, and then we're going to speak something. You have a new message from that sender's name. Then we're going to pause again, and then we're going to speak the text of the message. And then we're going to say, this is a message from, right? So what I like about this is actually beginning to see all the pieces in place as you go along. This is a great example of how you'd want to do text-to-speech, because it's something that you might want to listen to while you're driving or while you're distracted. There are some really nice examples from Amazon Alexa, like setting a timer. It's so nice to just be able to say, hey, set a timer for 20 minutes. It's so nice to do things for very bounded contexts, like music. Hey, Alexa, play me some Bob Marley. So these are just 3 examples of things that you can do. Incoming short messages that you want to be spoken back to you. Setting simple utilities, playing music. These are all things that you could end up doing with these APIs as well. So to wrap up, 30% of all of our interactions with computers are going to be doing what we just did here. This is the perfect time for us to start getting good with this. I mentioned yesterday that I was sitting in an airport lounge with a recruiter, and she told me that she cannot hire AI folks, machine learning folks fast enough. And they're being placed in Silicon Valley jobs at Amazon, at Microsoft, at Google for $300,000 to $500,000 a year. This is a hot area right now. And so whether you use something simple and free to get started, or begin playing with cloud services, but cloud services that you control, or you go pure SaaS, pure software as a service, and defer that out to everyone else, we just demonstrated Watson. Of course, Google has a set of APIs. Of course, Microsoft has a set of APIs. There are lots of different services out there. This will probably be the most common use case, but dealing with this on mobile platforms, I think, is going to be the most compelling use case. Because remember, Android is now the most popular operating system in the world. That internet traffic has now surpassed desktop traffic on mobile devices. Fully half of the world uses mobile devices to access the internet versus desktop devices or things like that. So this is why I think conversational UIs are going to be the real sweet spot, because they're converging with a lot of other converging trends, and smartphones is among the biggest among them. So we had a lot of fun here. Did you enjoy yourself? I did as well. Thank you so much for your time and attention. I really do appreciate it.